This is lesson 4.4 on translations of conics. So this is the last section that we have for chapter 4. We've been working pretty heavily with conics through section 3. Now we're going to be shifting them so that their vertexes and centers are no longer at the origin. So if you guys would all please turn to page 343, we will get this one started. Now, the table on page 343 has what I would like you guys to add to your note sheet. It gives you, at the very top, don't forget the circle part. They don't have a diagram or anything with it, so it's easy to miss that. But then the information for the ellipse, hyperbola, and parabola that have been shifted are provided for you there. So, the shifted circle, okay, so without the origin being the center, notice that h and k have come back to our formula. When it was at 0, 0, that's why we didn't see any numbers there, because x minus 0 would have just been x squared. The center, of course, reviewing, is hk, and the radius is r. Remember that in the formula, you're going to have r squared, though. So if there's a number in that place, remember that your radius is going to be the root of that. Here's your information for your parabola. So go ahead and please take a couple moments to copy this down. You're going to see that it's very close to what we were looking at before, outside of the fact that h and k are in there. So I'm just going to give you guys a few seconds. If you want to pause it right now to finish writing, that would be fantastic. Same thing for the ellipse here. So here is our equation information. Center, again, is going to be represented by hk. We've got the horizontal version of it, the vertical version of it. You're going to recognize them from the other day. You guys are pretty solid on that. The length of the major axis is still double what A is, so when you have that major axis, cut it in half to get A alone. The minor axis still provides us with our B length, so if you have the length of the full axis, cut it in half, and you've got a single B. Okay, so again, get this all written down and then continue. Hyperbolas, here's your information for your hyperbola. The h and k again are present. You can see that we have the transverse axis being horizontal versus the transverse axis being vertical. Again, they look very similar to what we were seeing in 4.3. Also along with this though, okay, I'm going to jump back a little bit. Look at page 430 or 343, and there's more on, well, actually, no. The asymptote stuff would still work from 4.3, so I take it back. That's why I didn't type it again. So this is pretty much the new stuff that you're going to be looking at. All right, moving on. Checkpoint number 1 on page 346. So actually, checkpoint 1 is on page 344. Goes along with example number 1 that's in your textbook. So I'm doing a couple of them from the bottom of that page. I'm going to do A and I'm going to do B. So first of all, we're going to identify the conic. Actually, I think I might have C and D on the next slide, I believe. So let's take a look at this one together first. In looking at this format, if we sat back and looked at this, we can definitely see that we don't have a center or a vertex of an origin, but I can tell that I have an x squared and a y squared portion, so I know that the parabola is out. With the plus sign in between, I know that the hyperbola is out. Without any constants here or here. Okay, I guess I didn't know what the letter is irrelevant here, but there's no constants there. If I were to change the right-hand side to a 1, I wouldn't have differing axes. So this one ends up being a circle. Okay, can you see the x minus h squared and the y minus k squared is equal to r squared? So we have a circle for our conic, and now we need to describe that translation. How are they sliding it? Well, if we have an x plus 1, that means that our h must have been negative 1, and our k in that y minus 1 spot must have been a positive 1. So if our center of our circle is now at negative 1, 1, we moved left 1 and up 1. Let's take a look at the next one. All right, I can again see that I have an x squared and a y squared, so we do not again have a parabola. I see the plus sign in between, so I do not again have a hyperbola. So we're down to either a circle or an ellipse. With the different values underneath, the 9 under the one and the 25 under the other, and the 1 on the right hand side, we can throw out the circle. So we must be looking at an ellipse. Look for the center of your ellipse. Our center is going to be HK again. So negative 1, 2 is our center. So that means we have, from 0, 0, moved left 1 and up 2. Next slide, letter C. All right, again, we've got an x squared and a y squared, so the parabola is again out. We have different numbers underneath, so the circle is out. And we have a minus sign in between this time, so the ellipse is out. We are looking at a hyperbola. The center of that hyperbola is going to be found at 3, 1. So our shift or our transformation was right 3 and up 1. Next one. On this one, notice that there is only an x squared portion. All right, so we are definitely not looking at circles, ellipses, or hyperbolas. We must be looking this time at a parabola. So what I'm going to do right now is I'm going to take this portion of my parabola, because as we've been studying it, that much of it, everything but the x squared part, would be on the right-hand side. So rewritten, we would have a positive 8y minus 3 over there. So now, again, we said, or we determined already that this was a parabola. So identify your conic. We're looking at a vertex, this time of negative 4, 3. So our shift must have taken us left 4 and up 3. Moving on. Checkpoint number 2 on page 345. Find the vertex, focus, and directrix of this parabola. Then sketch it. All right, so there's going to be a number of steps to these where we have to rewrite them into that standard form so we can get our vertex. So make sure you've got plenty of room in your notebook for this one. This part gives away whether or not this is going to be an up-down tipping parabola or if it's going to be left or right. We know because we've been studying the y-squared parabolas that they are our sideways turning ones. So I'm going to keep all of my y material on one side of my equation, and then I'm going to move that 4x and that 17 to the other side. So I'm going to come over here, though. I'm going to leave y squared minus 6y alone, and negative 4x minus 17. I'm going to move that other stuff over to the right. Now, in this one, it's pretty obvious that we're not going to have a vertex at 0, 0. So I need a y minus k squared over on that left-hand side. I'm going to have to complete the square to get that. Okay, so remember that completing the square. First of all, you want a 1 out front, which we do, so we don't have to factor anything out this time. The next thing you do is you look at that coefficient of y, you cut it in half, and you square it. So half of negative 6 is negative 3. Squaring that, we get a positive 9. I want to insert a plus 9 to the left side of my equation. I need to balance, so I'm going to also have to add 9 to the right-hand side. All right, so factoring my front, I'm going to get that y minus k squared part. So y minus 3 is how that would factor. And then I can simplify a little bit of stuff over here. Now remember, we're looking for y minus k squared is equal to 4p x minus h. So we don't have a factor including our x yet. So the way to create that, okay, I'm kind of, whoops, I don't want a 3 there, I want a 2. Sorry, that's a squared. I'm going to factor what I can out of the two parts of my right-hand side. I can take a negative 4 away from the negative 4x and the negative 8. So I'm going to start by doing that, and that gets me here. Okay, so now I can see my x plus 2. I've got that h part for along with my x, but if I'm going to sketch that, remember I also need my focus and my directrix. So remember how we practice rewriting the number attached to our x stuff as 4p? So right now I need to rewrite negative 4 as 4 times a number. This one's not so bad to see. I'm going to have 4 times negative 1, and then that x plus 2. All right, so here's P. Now I'm ready to write my stuff and do my sketch. Okay, so my vertex. First of all, I can get that from this equation. X has a positive 2 with it, so H must have been negative 2. Y has a negative 3 with it, so K was 3. So my vertex is at negative 2, 3, and I can plot that. P is negative 1. I know that this thing is going to be sideways facing, so that negative tells me it's going to open left. That distance puts my focus point right here. All right, so if I have to identify my focus, it would be the point negative 3, 3. My directrix has to go that distance of 1 behind my parabola, and that equation is x equals negative 1. Okay, so there's your sketch of the parabola. It says find the standard form of the equation of a parabola whose vertex is negative 1, 1, and whose directrix is y equals 0. All right, so they're handing us the vertex. That's nice. We already have h and we have k. You guys need to decide, or the first thing we need to figure out is which way does this parabola tip. So let's take our information. Remember how I suggested doing these little mini sketches off to the side? Here's my vertex, and the x-axis right here is my directrix. So I must have a parabola that's going to do this. So I know I've got one of those x squared ones. So I'm looking for x minus h squared is equal to 4p y minus k. All right, so pull that right off your sheet, put it down on paper, and then start figuring out what we can already fill in. We have h, we have k. Okay, technically, if you look at your vertex compared to your directrix, you also have p. Remember, p is that distance from your vertex to your directrix and your distance to your focus as well. But see how they are 1 apart? Okay, so that distance there we already have as well. Got a distance of 1. So let's plug all of our stuff in. H is negative 1. So inserting that, I now have x plus 1 squared. P is 1. K is a 1. So simplifying then, we end up with that. Checkpoint number 4, it says sketch the ellipse. Remember, ellipses have both x squared and y squared portions. This one, again, is a transformation of an ellipse, so we're not going to have a center at 0, 0. Therefore, we're going to have to find h's and k's. They're not handed to us, so we're going to be doing a couple of complete the squares to create that part. So my first suggestion is group up your x stuff, group up your y stuff, and then any constants, push them off to the right-hand side. So I'm going to take my 9x squared and my negative 36x. Then I'm going to have my 4y squared and my plus 24y. And I'm leaving space in there because I already know that I'm going to be doing some complete the square work. And like I said, move 36 over. Okay, so now focusing just on that front portion. I cannot have a number out in front of x squared if I'm going to complete the square. Factor out the 9. Now do the completing of your square. -4 is my coefficient. I'm going to cut that in half, and then I'm going to square it. So cutting it in half gives me a -2. Squaring my -2 gives me a +4. Now, when you balance, okay, I'm going to come over here and write what I already have down. I didn't technically just add 4 to that side. Because of this 9 out front, that actually had a value of 36 to it, to my left-hand side. So that 36 needs to be balanced with a 36 over here. Let's do the same process for our y stuff. Again, I cannot have this number in front of the y squared, so I'm going to pull it out. Half of 6 is 3. Square that is 9. Again, determine what value you actually just tacked on to the left-hand side. With that 4 out front, that 9 that you just inserted actually is another 36. So I give myself another 36 over here. All right, let's do our factoring. We've got a 9, and this is going to factor into an x minus 2, x minus 2. This one, the 4 is out there, and we have a y plus 3 and a y plus 3. And over on the right-hand side, the -36 takes out one of the positive 36s, and we just end up with a 36 total. Now, with our ellipse, we know we want a right-hand side of 1. So we're going to divide everything by 36. Reduce. I don't know why I keep writing 3's here. Sorry. You guys probably caught that already. And we're done. Now if we're going to sketch this, of course you got to remember how to figure out which way this ellipse is going to orient itself. The big one is always the major. So with A sitting underneath the y squared part, we know that we're going to have a vertical one. So let's go ahead first of all by figuring out our center. The center looks to be at 2, -3. So go ahead and plot 2, -3. Okay. Then with A equal 3 would mean B is equal to 2, right? With that larger number being under my y square part, I know I'm going to have a vertical ellipse. So my vertices are going to be above and below that center. So if A is 3, go 3 above and 3 below. There's your major axis. B is 2. Go 2 to the left and 2 to the right of your center. And there's my ellipse. Checkpoint number 5. Find the standard form of the equation of the ellipse whose vertices are 3, 0, and 3, 10. The length of the minor axis is 6. Now remember from our discussion so far this chapter, minor axis results in B. All right? The whole minor axis is 6, which means that B must be 3. All right? So that piece of information we've got. Next thing again, we need to figure out how this ellipse orients. So is it going to be a vertical or is it going to be a horizontal? Let's use our vertices to tell. Let's do that quick sketch thing. So 3, 0 is here. 3, 10 is going to be above it somewhere there. So you can clearly see that your vertical major axis is sitting there. So if we've got a vertical for our major, that lets us know that B squared is going to be underneath our x squared part. So here's the format we're looking at. We're going to have our x minus h over B squared plus, because it's an ellipse, y minus k squared over a squared is equal to 1. All right, now here's some more information we can figure out. These 2 points here at 3, 10 and 3, 0, those are the entire, that's the entire major axis. Okay, those are our vertices. Those are on the ends. So our center has to be midway in between right here. So smack dab in between 3, 0 and 3, 10 would be 3, 5. So there's our center. Okay, if that is our center, the distance that we're looking for A is from the center to one of those vertices. So A is right in here. Must be the length of 5. got everything that we need. So let's come back here and put in our center and then put in our a's and our b's. So x minus 3 squared over b squared plus y minus 5 all over 25 equals 1. And there we go. Moving on into some hyperbola stuff. A couple more things to go. Again, I know I'm going to either end up, a parabola is voted out even if they didn't tell us this was a hyperbola, because you've got x squared and y squared stuff. The fact that we know, because of the question, that we are heading for a hyperbola, I know I'm looking for an x minus h squared again and a y minus k squared again. So like the last problem, I'm going to group up my x stuff and my y stuff. So 9x squared, put the negative 18x sort of kind of by it. I have a negative y squared in my problem. It's going to partner up with the 6y. And again, I'm going to kick out my constant. I'm going to put the 9 on the right. I will have to complete my square, so I cannot have the 9 there. I'm going to factor it away. So half of my x coefficient, half of negative 2 is negative 1. Squaring negative 1, I get a plus 1. Determine whether or not that really is only worth a 1. Okay, because I have to balance out my equation. That 9 on the outside and that 1 on the inside actually means I've just tacked on a value of 9. So along with that I already had, I just got 9 more. In the middle, I'm going to go ahead and factor out that negative 1. I want a positive y squared for completing my square. Half of 6 is 3. Square that, I have 9. Technically, the value that I just gave myself there with that negative 1 outside was a negative 1 to my left-hand side, or negative 9 to my left-hand side, sorry. So I need a negative 9 on the right-hand side. All right, go ahead and do your factoring. X minus 1, x minus 1. Y plus 3, y plus 3. And then my right-hand side simplifies to simply 9. Okay, a hyperbola needs to have a 1 on the right-hand side, so I'm going to go ahead and divide everything through by 9. So I end up with an x minus 1 squared over 1, a y plus 3 squared over 9 is equal to 1. So from there I can find my center. I ended up with 1 and negative 3 as my center. Okay. I need to figure out whether I've got a horizontal or vertical here again. It's going to be a horizontal because the x squared portion is on the left side. So I also know from this, because a is always under the first one, if a squared is 1, a is just 1. This guy's got to always be the b squared, so b is 3. So now if I'm going to come over here and sketch, the first thing, the easiest part to put on is my center, 1, negative 3. I have a horizontal. I'm just going to write that so I can't forget. I have a horizontal transverse based on how my equation set up. So my vertices are going to go left and right from there. If a is 1, one of my vertices is 1 this way, and the other vertice is going to be 1 this way. B is 3. Okay, so 3 up and 3 down. Now remember how we talked a couple of ways how we can sketch. A and B, if we kind of box them with our rectangle, try to move this out of the way, my diagonals form my asymptotes. That's one way to come up with your asymptotes for your graph. I don't want my curve to go past those blue asymptotes. So when I go and graph here, my hyperbola is going to go as fat as those asymptotes allow me to get, because they'll skinny right along them forever. Okay? The other way to come across that asymptote, if you remember those equations with b over a and all that kind of stuff, think about what we'd have there. If we looked at those equations and we tried to come up with them, our slope from our center to, with our A's and B's, we had up 3 over 1 and down 3 over 1. So you could have actually sketched those lines using your B's and A's and your note sheet. Okay, but the sketch with that rectangle boxy thing works just as well. Last one. Find the standard form of the equation of the hyperbola whose vertices are 3, -1 and 5, -1, and whose foci are 1, -1 and 7, -1. All right, so if we're going to come up with the standard form of the equation, we need to know which one of the two patterns to use. So let's use our vertices again. Quick sketch. 3, -1, 5, -1. Our vertices line up horizontal to each other, so we have the horizontal setup. Okay, so we want to go with x minus h squared over a squared minus y minus k squared over b squared equals 1. All right, we have our vertices already. Remember that the center is going to be smack dab in between them. This has to be your center. Okay, that wasn't the greatest of drawings here. My pens aren't exactly hitting where I'm trying to get them to hit. Let me do the sketch real quick again. I'll make it a little bit bigger. So my 3, -1, 5, -1. So my vertices are there. My center has to be right in between them. Okay, so I already know my center. My HK must be 4, -1. Okay, my focus points give me some more information. I have one focus point of 1, -1 and another focus point of 7, -1, 6, 7, -1. So from my center to a focus, this distance, remember, is C. So I just went 3 spots. So C is equal to 3. This distance was my A distance. Okay, distance from the center to a vertice is always A, so I've got my A distance as 1. Now I can use my relationship that we talked about. For a hyperbola, we have b squared equals c squared minus a squared. Plug in the 2 that you have, we'll find the b that we don't. So b squared is equal to 9 minus 1, or b squared equals 8. Okay, we've got everything that we need now to come back over and fill in our stuff. The center was 4, -1. So x minus 4 squared, y plus 1 squared are our tops. A squared is going to be a 1. 1 times 1 is 1. And then b squared we just found was equal to 8. And we're done. Now, like I've been preaching this chapter, the amount that you do is going to increase your comfort level. So I will force us to do a whole lot of them in class together. I would like you guys to take it upon yourself to do a whole lot more of them outside of class. The more the better. You guys had a pretty firm grip on the 4.3 before we shifted our centers, so hopefully this isn't going to be a whole lot more. Really, the added part is the completing the square when needed. All right, so if you need help with that process, remembering how to do it, just let me know.